Hello friends, now we will discuss a limiting property of a Poisson distribution. So Poisson has made a contribution. He starts with binomial distribution and arrived a particular formula. So that is nothing but a Poisson distribution. So we can start with a binomial distribution, and we know that the probability mass function of a binomial distribution. So what is those if this is a binomial distribution with parameter n and p? If n tends to infinity, means what? The experiment is performed n number of times, infinite number of times, and the probability of success p tends to 0. So with these two conditions, we may get np equal to lambda. So lambda is a constant. So we can start with a binomial distribution. So what is the probability mass function of a binomial distribution? So that is ncx p to the power x q to the power n minus x. So this is the probability mass function of a binomial distribution. Friends, what is this ncx? So ncx is nothing but n factorial divided by n minus x factorial and x factorial. We know the formula of a combination, ncx. So this is p to the power x and 1 minus p to the power n minus x. Since we know that in a binomial distribution, q is nothing but 1 minus p. P stands for probability of success, q stands for probability of failure, and the probability of happening and non-happening of an event is always 1. So what is this? This is what? So n factorial is what? N into n minus 1, n minus x plus 1 and n minus x factorial. So here it is n minus x factorial. But I can cancel this n minus x factorial with the denominator n minus x factorial. So n factorial is this term divided by x factorial. And what is this p? So p is nothing but what? As we know that np equal to lambda. So this simply means p equal to lambda divided by n. So I am just putting the value of p as lambda divided by n raised to x. So therefore this numerator is lambda to the power x, and I am writing in the denominator as n to the power x. And this is same as what? P is lambda upon n. So 1 minus lambda upon n raised to n minus x. See friends, this is n raised to x means what? N is repeated x number of times. And how many terms are there in the numerator? See, this is the first, this is the second, this is nothing but what? Minus x minus 1. So x minus 1 is nothing but the x term. So in the numerator there are x terms, and this x n to the power x means n x times. So again there are x terms in the numerator. We can divide it by n. So this means what? N divided by this n is 1. N minus 1 divided by n is 1 minus 1 upon n. So likewise, n minus x minus 1, that should be divided by n. Means what? 1 minus x minus 1 divided by n. So this is x factorial. So I am writing the same this in the denominator, lambda to the power x, and I am splitting this term. So this is what? 1 minus lambda upon n raised to n, and it is multiplied by 1 minus lambda upon n raised to minus x. So this is what? If I take a limit as n tends to infinity, see this is the condition as n tends to infinity. What happens? As n tends to infinity for binomial np, so this is what? This is 1. So 1 upon n. So 1 minus 1 upon n means what? As n tends to infinity. So 1 upon infinity is 0. So 1 minus 0 is 1. So likewise 1 minus x minus 1 upon n. So as n tends to infinity, if you impose limit here, so this means what? X minus 1 divided by infinity. So some constant value is there. Divided by infinity is 0. 1 minus 0 is 1. So the numerator term comes to be 1. So this x factorial, I am writing x factorial. This is lambda to the power x. I am writing the same. So what about this value? So what is this? So this is 1 minus lambda upon n to the power n, and as limit n tends to infinity. So this is the standard formula, and this formula is what? So this is same as e to the power minus lambda. So limit as n tends to infinity, 1 minus lambda upon n raised to n is e to the power lambda. So I am writing this value as e to the power minus lambda. And what about the rest thing? So as n tends to infinity, 1 minus lambda upon n raised to minus x. See, this is the last quantity. So if you take limit for this, so limit as n tends to infinity, 1 minus lambda upon n raised to minus x. This is what? So as n tends to infinity, lambda upon infinity. So lambda upon infinity is 0. So 1 minus 0 is 1. So 1 to the power minus x. This is what? 1 to the power minus x is 1 upon 1 to the power x. And 1 is taken x times. So 1 x times. Again it means 1. So 1 upon 1 is 1. So this quantity is 1. This quantity is e to the power minus lambda. This is lambda to the power x. And this whole numerator is taken as 1. So this is same as lambda to the power x into e to the power minus lambda divided by x factorial. And this we can write as e to the power minus lambda, lambda raised to x divided by x factorial. And the value of x takes as 0, 1, 2 like this. So this is nothing but a Poisson distribution with parameter lambda. So we start with binomial distribution and we will get a one more distribution. So that is nothing but a Poisson distribution. Therefore, so this binomial distribution, or we can say that Poisson distribution is a limiting case of binomial distribution, because we start with binomial and arrive up to Poisson distribution. So this distribution is very important as far as the literature of statistics is concerned. We will continue with more calculations in the Poisson distribution. So friends, up to that, goodbye.